Hi guys, welcome to Amateur Chemistry. So today's video is actually a second part of a series that I have been making for a while now, which is about making silane from dirt, and in the first part I turned the dirt into some pure silicon dioxide, so if you haven't watched it yet, I recommend you to check it out, and in this video I will do the second step of this project, which is converting the silicon dioxide into pure silicon. Silicon dioxide is just a silicon atom bonded to two oxygen atoms, and all that I have to do to make some elemental silicon is to get rid of these two oxygens. On paper, it might sound pretty easy, but as these things always go, it is not so easy in practice. The bonds between silicon and oxygen are very strong, and there are two main ways of breaking them. The first one is the electrolysis of molten silicon dioxide, which is ridiculously complicated, requiring very expensive equipment and a constant temperature of over 1700 degrees Celsius, which is just way beyond my capabilities. The second method, however, is much more accessible to the amateur and involves the use of a thermite reaction. I am sure that most of you know what thermite is, but most people only know about the most basic and widely used thermite, which is the iron oxide and aluminum thermite. It is prepared by weighing out stoichiometric amounts of iron-free oxide and aluminum powders and mixing them very thoroughly. Here I make some of it by mixing 7 grams of aluminum powder with 20 grams of iron oxide powder and placing this mix into this contraption. It is very hard to ignite, and to get it to burn, I had to use a piece of magnesium metal. Once ignited, it burns very vigorously, looking like some kind of volcano, and like a volcano, it is very hot, which resulted in my steel can being completely melted. Also, on the bottom of the can, I made a small hole to collect the product of this reaction, which is molten iron. That's right, this reaction ripped the oxygen atoms of the iron and transferred them onto the aluminum, creating aluminum oxide and elemental iron, which melted because this reaction generates enormous amounts of heat. As you can probably guess, this reaction is what allows me to turn silicon dioxide into pure silicon. However, in this specific case, there is a big catch. You see, when a thermite reaction results in a formation of a metal, it is pretty easy to separate it from other oxide products because it is much harder, and it is exactly the case with the iron oxide aluminum thermite. However, in the case of silicon, it is not exactly a metal and is also very brittle, which means that by smacking with a hammer, it would be impossible to separate it from the other products. There is a solution to this problem, which is very stinky, and it just basically involves the use of a lot of sulfur. I won't go into much detail about why the sulfur is necessary just now, and instead I now have to wait out the ingredients. The first one is of course my silicon dioxide, but before I can use it, I first need to grind it into a powder, because this reaction only works when the ingredients are finely powdered. I used my mortar, which is stained with a lot of Prussian blue that I still don't know how to clean off, and when the silicon dioxide was a nice powder, I weighted out 18 grams of it on my scale. I then proceeded to add 20 grams of aluminum powder as my metal. Different metals such as magnesium can also be used, and the general rule for making thermite work is that the metal used to reduce the oxide must be more reactive than the reduced one. Anyway, I then proceeded to add 24 grams of sulfur into the mix, and I promise that I will explain what it does in just a second. I then mixed all of the ingredients thoroughly and put them into a bowl with some sand to prevent it from being disintegrated like that can earlier. I then put a magnesium shaving into the mix and ignited it. It burned very brightly and vigorously, and when I thought that it stopped, it started to burn again. The reactions that are going on in here are pretty simple, and the silicon dioxide is reacting with aluminum producing silicon and aluminum oxide. The excess aluminum reacts with the sulfur, forming aluminum sulfide. All of the products melt, forming a small glowing puddle that looks just dangerous. After it cooled down, I got the beaker that I broke in the fluorescing video as a potential sacrifice and collected the hot reaction product. I'll then let it cool to room temperature, and the next step was to add about 100 ml of concentrated hydrochloric acid. The acid reacts with the aluminum sulfide, forming aluminum chloride and hydrogen sulfide. That's right, this reaction produces an incredibly toxic, flammable, and worst of all, incredibly stinky gas that is just a pain to deal with. The reason why I added the sulfur was not to die of stink, but to make the silicon easier to remove from the aluminum oxide. Both of them are very brittle and not too reactive, but the addition of sulfur and the production of aluminum sulfide allows the acid to dissolve the sulfide, leaving behind a powder of aluminum oxide and untouched blobs of elemental silicon. This is a very easy way of gently separating the silicon from the rest of the junk, but it has the massive downside in the form of the formation of copious amounts of hydrogen sulfide gas. This gas is very poisonous, so I had to use my respirator and a fume hood to be safe, but it also has a horrible stench of rotten eggs, which is detectable even in the parts per billion, meaning that literally my whole lab now smells like rotten eggs. Anyway, I added another portion of 50 ml of the acid for good measure, and left the mixture to react for the night. When I came back in the morning, the smell was mostly gone, but the reaction was still going on very slowly, but I just ignored it and proceeded to the next step. I now had to remove the junk from the silicon, and to do that, I firstly vacuum filtered the whole mixture, and after that, I washed it with a lot of distilled water to remove all of the soluble stuff, and I was now left with some kind of a weird sand. This sand actually contains all of my precious silicon in the form of small beads mixed with a lot of aluminum oxide. I have to handpick all of these small beads, and for the big ones it is very easy, but most of the silicon is actually in these tiny beads that are hardly visible, and picking them up is just a pain. I ended up using a pair of tweezers, and after about 40 minutes of painstakingly picking up these little beads, I was left with a pretty decent amount of them. I mean, this isn't even close to being a good yield, but I don't want to make my whole neighborhood smell like rotten eggs again, so I just have to use what I got. To purify the beads even more, I washed all of the bigger ones using a test tube, which removed a lot of the aluminum oxide along with some of the silicon, but it wasn't too big of a loss, so I just proceeded to clean the smaller ones. It wasn't as easy as just using a test tube, and I had to soak everything in a good amount of distilled water, and then again handpick every single of those little beads, which took forever, but in the end, I was finally left with some nice and clean beads of pure silicone. I now had to weigh everything, and it turns out that I only got 1.8 grams of the silicone, which is a terrible yield and will barely be enough for making the silane in the next video. I could make more, but as I already said, I don't want to experience the terrors of hydrogen sulfate again, so 1.8 grams must be enough. I put all of the beads into these cute tiny vials, and I saved the 3 biggest ones for my element collection. I will use the smaller ones for the silane video, and if you don't want to miss out on it, you can subscribe to my channel. And before I end this video, I just wanted to let you know that I have a Patreon now, and if you want to support my channel and gain access to some of these spicier videos, you can become a Patreon. I already have 4 patrons, to whom I'm very thankful, and special thanks go to the $5+ ones, who are R2D2 and Riley Reprogo, So again, thanks for the support and see you guys in the next video.